Welcome students for today's lecture on design of steel structural elements. So in the previous lecture, that is lecture number 3, we had started with a numerical and we have completed the steps that are load calculation, then check for moment of resistance of the beam, then check for shear. We have done for those steps. So today we will continue the numerical and just check the further steps, that is check for deflection, check for web buckling and check for web crippling. So before starting, let us see what all we had done in the previous class. So I will read out the numerical once again. A simply supported beam of ISMB 350 at 54.4 kg per meter is used over a span of 5 meters. The beam carries an UDL live load of 20 kN per meter and dead load of 15 kN per meter. The beam is laterally supported throughout. Check for the safety of the beam. So initially we noted down what was the given data. Then with respect to the section, we noted down the properties of the section from the steel table. Then in the first step we calculated the load calculation. So the self weight of the beam was taken from its weight, that is this weight, and converted into kilonewton and meter format. Then live load and dead load was given in the question. We substituted, we found out the total load by addition of all these. So this is the unfactored load. Then we multiplied this load with 1.5 to get the factored load or ultimate load. Then as the beam was simply supported and a UDL, so we calculated the bending moment and shear force for the condition simply supported with UDL. So this is the formula to calculate bending moment and this is a calculate shear force. So we got the values. Then we started with the step number check for shear. Herein we wanted to check whether the value of VO is less than 0.6 VD or no. So initially we started with this clause number. We computed VD where AV is the area of the web portion. So H into TW. And we calculated VD and we just checked whether it is less than or greater than 0.6 VD. So accordingly we got the section as safe. Then we started with the moment of resistance of the beam. As we already concluded in the check for shear that VU is less than 0.6 VD. So it is case 1. So case 1, for this condition, that is VU less than equal to 0.6 VD, this is the formula to be used. So we use this formula. In this we need to calculate beta B. To get beta B, we need to have the section classification. So we started with that. Then we found out the ratio and checked which type of section it is. So the section worked out to be plastic section. So for the plastic section, beta B is 1. Then we needed ZP. ZP we noted down from the IS 800 itself from the table 40. And then we calculated MDD. So we checked that MD is greater than the calculated bending moment. Hence it is safe. So today we shall start with the next step. So the next step is check for deflection. So let us start. So next step is check for deflection. Now as we know that our beam is like this, simply supported with the length 5 meters and it is a UDL where the format is W, which is in terms of kilonewton per meter. So I will just take you back to the lecture number 1. So we had discussed this is how the deflection is to be calculated. So what is permissible deflection? Span divided by 250. So let us compute. So permissible deflection is span divided by 250. So our span is 5 meters. So I will write it as 5000 mm divided by 250. So let us check how much we get. So 5000 divided by 250. So it is 20 mm. What is the meaning of it is that the allowable deflection in the beam should be up to 20 mm. That means the deflection when we calculate for the given beam, it should be less than 20 mm. So I had given some formulas for the standard section. Let us see. So here I have given deflection for some standard section. So what is our case? Our case is simply supported beam with UDL. So it fits in here, simply supported beam with UDL. So what is the deflection given? 5 by 384 into WL raised to 4 divided by ES into I. Where I have given a note, here the W is the unfactored load, remember. So W is unfactored load. So however we have calculated in our first step, this is the first step. So this is total load 35.524 kN per, which is unfactored load. So we have to consider this, not this one, remember. So we have to take with the unfactored load 35.524 kN per meter. So we shall substitute it here. So W is 35.524 kilonewton per meter. I will write here that it is a unfactored load. Now let us calculate the deflection in the beam. So the deflection in the beam is given by deflection is in the beam is given by delta is equal to phi divided by 384 into W L raised to 4 divided by ESI. So let us substitute here. Now this, remember, this formula depends on what type of loading is there on the beam. This formula is for simply supported beam with UDL. So let us substitute. So 5 divided by 384 into W is nothing but this load. So this is 35.524 into the span. So span is 5000 mm raised to 4 divided by, remember, ES is nothing but the modulus of elasticity of the steel, which is standard, which is 2 into 10 raised to 5 Newton per mm square. And we want I is nothing but moment of inertia, which has to be taken from the steel table. So let us go to the section again and check for the steel table. So what is our section? Our section is ISMB 350 at 52.4 kg per meter. So let us know from where it is. So this is the steel table. So this is a section ISMB 350 at 52.4 kg per meter. So IXX is given here, that is moment of inertia, that is this value. So note down this value from here. So IXX is equal to 13630.3. It is in terms of centimeter 4. So let us convert it in terms of mm. So into 10 raised to 4 mm raised to 4, which is nothing but IZZ. So this I has to be substituted as IZZ, which is equal to IXX. So let us substitute this value here. So this is 13630.3 into 10 raised to 4. Now let us check what is the deflection in the beam. So it is working out to be 10 point deflection is working out to be 10.604 mm. So how much deflection we got? deflection we got it as 10.604 mm, and what is the maximum permissible deflection? It is 20 mm, so it is less than 20 mm. Hence beam is safe in deflection, or section is safe in deflection. Now let us go with the next step. So I will write it here only. So next we'll go for check for web buckling. Now let us see what we had discussed about check for web buckling in the steps which we had discussed earlier. So this is, so check for web buckling, which is on the page number 67 of IS 800/2007. This is the formula which I had given. So I have just converted the formula. FWB is equal to B1 plus N1 into TW into FC, where N1 is S divided by 2. FC is nothing but we can calculate it from the table from design compressed stress. How do we get it? By calculating the lambda value. So first let I note down these components. So the formula I will note down. So the formula is, here I will be writing, so this is a formula. So this is FWB is equal to B1 plus N1 into TW into FC, where N1 is H by 2 and FCD design compressive stress how we get? By calculating lambda. So lambda is 2.5 into T divided by TW. So this I would like to show you in the clause. So from which clause we have noted down? Remember, so buckling has taken from this clause. So check for buckling from clause 8.7.3.1 page 67 of IS 800/2007. You can see here B1 plus N1 into TW. So this I have multiplied with the stress. So I will get directly the buckling strength. Buckling strength. So let us compute now. So let us compute first N1. So N1 is H by 2. So what is H by 2? We already know our section. So this is our section. So H is 350, so divided by 2. H is 350 divided by 2. So how much this works out to be? This works out to be 175 mm. Next P1. Now here they have not given the cross section for the column, or they have not given the thickness of the wall. So we can assume. So I will assume it as 300 mm as bearing length assumed. If nothing is given, you can assume it in between 200 to 500 mm. Let us assume it as 300. Now let us calculate the slenderness ratio. So this is given by 2.5 into D divided by TW. So 2.5. Now what is D? So D we have already given in the section. D is nothing but H minus 2 times of thickness of the flange. Divided by the thickness of web. Now substitute in this the components. So remember, thickness of flange is 14.2 and thickness of web is 8.1. So let us compute how much is this. So this is working out to be 99.259. So we have now lambda value. Why we are calculating this lambda? Because we want the value of FCD. So we have lambda, and Fy we already know it is 250 Newton per mm square. So go to the component, that is table number 9C. So I'll write here, go to table 9C of IS 800, which is on page number 42. So here it is, page number 42, table number 9C. This is nothing but the lambda value. So what is our lambda value? 99.259. So you can see what all values, 90 is there and 100 is there, then against 205. Now in actual, you have to actually calculate what is the value of FCD for this value of lambda and this value of Fy. Now for easiness, I will just take the round figure. So 99.259 is there. I have a value here 100. So lambda is 100 and our Fy is 250. So what it is working out, the value of FCD is 107 Newton per mm square. So from table 9C, page 42, we came to know that FCD is 107 Newton per mm square. So let us substitute and get the value. So FWB is equal to B1 plus N1 into TW into FCD. So let us check how much is this. So this is working out to be so much, which is 411.682 kilonewton. So just check the calculated shear force. So the calculated shear force VU is 133. So obviously this value is greater than VU. Hence the section is safe. Hence the section is safe. So this completes the check for web buckling. Now we'll go for the last step, that is check for web crippling. So let us see what is we had discussed in the design steps. So in the design steps, you can see check for web crippling is given again on page number 67, clause number 8.744. How is the formula given? Fw is equal to B1 plus N2 into TW into FIW divided by gamma M0. So let us go to that page of IS 800 2007. So you can see. So this is the formula. So I will just note it down. Fw is equal to B1 plus N2 into TW into FIW divided by gamma M0. So this is taken from clause 8.7.4 page 67 of IS 800 2007. You can see here. Now again here there are components. So B1 is again same, that is the bearing width which we have taken as 300 mm. N2 is nothing but length obtained by the dispersion through the flange to the web junction at the slope of 1:25 to the plane of flange. Now that has been given here. So how to calculate is with respect to this. If the beam is resting like this, so 2.5 slope has to be applied, which works out to be like this. So how to calculate? Let us see here. So again, B1 we have already taken, so it will remain the same. So B1 300 mm. Again, it is assumed if the section of column is given or the width of the wall is given, you can take it. So let us calculate N2. Now N2, how is calculated? It is clearly mentioned that at a slope of 2.5. So 1 is to 2.5. So that slope condition I will write. Into I will convert into a formula. So this is thickness of flange into root radius. So 2.5 into thickness of flange is 4.2 and R1. Now what is this R1? This R1 you will get from the steel table itself. So I will just show it to you. So this is a steel table. This is ISMP 350 at 52.4 kg per meter. So here go on searching for root radius. So you will come across here and you will come to know that here it is root radius. Root at radius at root R1. So it is 14 mm. So it is from the steel table. So R1 is 14 mm. How much it works out? 70.5 mm. So let us substitute in the formula above. FWP. So P1 is 300 plus N2 is 70.5. Thickness of web is 8.1. FYW is 250 and gamma m naught is 1.1, which you will get from the table number 5, partial factors 50. Now let us compute how much is this. So this is 250 divided by 1.1. So this is working out to be 682.05 kilonewton. Now again, this is again greater than VU. Hence I will write the section is safe. Hence section is safe. So all the steps are over. We have completed the numerical. So we have solved for the whole numerical and we have got the answers, and on each of the checks it has been satisfied and safe. The meaning of this is